We're going.
All right. Hey, everyone. So what we're going to do today is we're going to demonstrate how we make clouds. And I'm going to do that by making a cloud inside of this jar. So let's take a look at this quick little sketch of the water cycle that I made. There's that sketch that we're all so familiar with, including, our evaporation, condensation, precipitation, and then the return of that water back into the ocean via either surface water or in the ground. Now, most of these steps make a lot of sense, right? Evaporation, that's easy, right? You heat up water, heat up any fluid, and it goes from the liquid to the gas phase, right? This step, I think, makes a lot of sense too. You get enough fluid up in the air, it wants to fall down. It gets too heavy to stay aloft. This step right here, the condensation step, that's the one that's a little unintuitive. And here's why. Because what we are doing right here is we are making the gas become fluid, but it needs to stay aloft somehow. It needs to somehow stay in the air. And so, if we think about it, well, what is it that makes anything go from a gas down to a liquid, right? Well, one of the things which we can do to make that happen is have the temperature go down. So what I'm going to do is right now I am going to pour some warm water into this jar, and I'm going to put some ice cubes on top. The warm water at the bottom of the jar, that's going to be an evaporating ocean, and the cool ice cubes up here, the ice cubes are going to be up here. That's going to be the cooler air that's aloft, right? Because the higher you go in the atmosphere, the cooler you get. So I'm going to do this, and let's see what happens. So you can see it kind of fogging up right here, but that's steam. That's not actually like a cloud or anything like that. Look at that. We're just putting some ice on top here, and I'm going to swirl this around. As you look inside the jar, right, you don't see any condensation, right? I mean, you don't at all. And that's because we have missed a critical element that is needed for condensation to occur. And that is particles. There have to be little particles up in the air for the water molecules to actually condense upon. So, now I'm going to add some particles. Here's what I'm going to do. I'm going to take some toilet paper and light it on fire. Future educators, maybe you want to do this one outside.
Or use a match.
Or use a match. Well, I'm out of matches. So here we go. Uh-oh. Whoa. Let's try this again. All right. And just drop it in. Woo! Closing it up. And now, I'm going to put this on to get some convective motion going. Did it work? Yes. There we go. If you look down, if you look very carefully in the back here, I'm going to swish this around. You can actually see. Does it work if you?
Yeah, I can see it.
You can see cloud falling off the top where the ice is. See it through my shirt?
Not very well.
Yeah, we need to make more smoke. Here's what we're gonna do. We're gonna tear up part of my water cycle. All right, that's gonna work. Oh yeah.
Oh yeah.
Oh yeah, look at that. Boom.
Totally. It's foggy in there and it's not condensation.
Yeah, foggy in there. It's not condensation. Kaboom. Made a cloud in a jar. So this just demonstrates the two things that we need. We need to reduce the temperature on our air, and there need to be aerosols, little tiny particles in the air for that water vapor to condense on. All right, now that I made this cloud, I'm gonna release it to the world. If you love something, you gotta let it go. Goodbye, cloud.
Yay.
Pretty cool. Bye-bye, cloud. Owen, look, there's a cloud.
Future generations.
Yeah, that's a cloud. We just made a cloud. See, there it goes. Whee! Can you say bye-bye, cloud?
Bye-bye, go.
All right.